Hi everyone, my name is Dr. Huba. In this lecture we will learn numerical integration technique, trapezoidal and Simpson rule. I'm going to start from trapezoidal rule. Do you know what's a trapezoid and trapezoid? Trapezoid looks like this. See here two parallel bases B1 and B2, and distance between two bases is h, and area of trapezoid is a half into h times sum of bases B1 plus B2. We make more difficult shape. It can be this shape. It's also trapezoid. Why? Because two parallel bases and distance between two parallel bases, right, is the h always, and one angle is 90. This is 90. This is also 90 degree. Okay, area again same, half times h times sum of bases. Now I'm going to implement this rule in integration technique, and we know integration is area under the curve. Now I'm going to calculate area under the curve through trapezoidal rule. So we are going to sum up n trapezoids from A to B. What's A and B? Is A is lower limit, B is upper limit, n is number of trapezoids. So now this first limit is A. I'm going to start from A, and last limit is B. We're going to add to B, and I'm going to make four trapezoids. I choose four trapezoids. This now 2, 3 and 4. It's not complete shape. Why it's not complete? Four sides here, and this is my segments x0, x1, x2, x3, x4, and now I'm going to complete trapezoids. One is completed, second trapezoid is third trapezoid, is the fourth trapezoid. So now what will be edge? Edge is always distance between two parallel bases. This is parallel bases B1 and B2, or this is H. This B is different. This is upper limit. This I'm talking about B1 and B2 is the basis of trapezoid. This is first basis. This is second basis, and similarly here. And we calculate in trapezoid area. H is equal to B minus A over N. B minus A means distance from upper limit to lower limit, and over N we're going to split into four segments. We can split into 6, 8 and so on. We do more, we get better results. Anyway, now I'm splitting into four trapezoids. Now we need to find the sum of the area of this four trapezoids, and then is equal to the area under the curve, right? If you calculate this first area of trapezoid, second area, and you then sum up these areas equal to area under the curve, right? So area would be 1 or 2 times h times two different bases, right? So here 1 over 2, h is here b minus a or n. We plug in, so then become b minus a over 2n, and first base is this y naught. This is y1. Means y naught means f of x naught plus f of x1. This is the area for first trapezoid. Now we adding four trapezoid area. So for second is b minus a, again b minus a over 2n, but now for two bases here is x1, x2, corresponding to x1, x2, y1 is f of x1 and x on x2, y on x2 is f of x2, and so on. And then for x3, x4, similarly. And then we add up these areas equal to area under the curve. Simplify 2. Now b minus a over 2n we take common, and f of x naught, f of xn. Okay, you know how to cram this formula. If you have 6 segments, 8 segments, and so on. What do? F of x naught, f of xn. Coefficients are f of x naught and f of xn is 1, right? And then you see 2 times, always, coefficients are same, and 2 f of x1, 2 times f of x2, 2 times, and so on. I guess you can remember this formula. I think it's not difficult. I generalize it, and we can find area under the curve, right? To this part, the bigger n you use, the more accurate your answer will be, right? So now I'm taking 4 trapezoids here because time is limited. Soon I'm going to integrate of sine x. So we have boundary says 0 to pi, and I'm going to split into 4 segments. First is 0 to pi, right? 0, pi by 4, pi by 2, 3 pi by 4, pi. Okay, and h will be, how we compute h. Here b minus a or n. B is pi minus 0, n is 4 segment. So first step is pi by 4, and then pi by 4 plus pi by 4, pi by 2 plus pi by 4 is 3 pi by 4 plus pi by 4 is equal to pi, and we have 4 segments. We make it, and now then see area of this integration. Area is equal to 102 h. H is pi by 4, and f of x naught or f of xn. This is right. F of x naught is at 0, at pi, both values see here 0, right? But anyway, we'll see later. And other coefficients are 2, and see here we plug in, right? And f of 0 means we have f of x is sine of x, right? Integration f of x dx, right? F of 0, sine 0 is 0, sine pi by 4 is root 2 over 2, sine pi by 2 is 1, and sine 3 by 4 is root 2 over 2, sine pi is 0. And then we get 1.896. If you do, without technique, you find similar, answer 1.896. Now we do we use another technique, Simpson's rule. We always split into in even steps. So we have formula, b minus a or 3n. This is 1 by 3 Simpson rule. Yeah, by 3 Simpson rule. But anyway, how to cram this formula? F of x naught, f of xn, same. And then here is orders like 4 2 4 2 4 2. And see here, the coefficients in Simpson rule have the following pattern, right? What are the patterns? Like 1 4 1 1 and 1 is constant, right? Fixed. This is f of x naught, this is f of xn. Coefficients for f of x naught is 1, for f of xn is 1. And then patterns like 4 2 4 2 4 2 4 2. And then we have same integration. Now see here, pi by 4, pi by 2, 3 by 4, pi, right? And then we plug in this formula b minus over 3n. See here, like we plug in here, you know, so like plug in and then compute 2.005. If we do more segments into 8 segments instead of 4, you will get 2.0003. You know, you get more accurate value. It's about 2, you know, is equal to 2. So this is numerical methods, you know, Simpson rule and trapezoidal. You know, here we conclude Simpson rule more better and give you more accurate result, but trapezoidal rule is you know, is the fastest method to calculate approximate answer. So it still again is approximated, but less error in Simpson. Thank you. Please subscribe my channel. Bye bye.